Uh, there it is. That's my reminder to record. So this meeting will be recorded. Participants, we will have you on mute for the duration of the presentation. We have a large group this evening and be quite a party if we could all chime in. You are most welcome to leave your camera on. Just remember that others can see you, and I see a few folks having dinner. It looks good. But do remember that others can see you. And if you're having bandwidth issues, sometimes it's helpful to actually turn your camera off. So feel free to do that if you're having problems. Please do submit questions into the chat box. And I think by now, probably everyone is familiar with the chat box. Direct your questions to everyone, not to our presenter, because he'll be busy presenting. Soren, I'll introduce Soren in a minute. My coworker Soren and I, Soren, give a thumbs up, you give a wave. Soren and I will be doing our best to answer your questions along the way, but we are not the experts, so we will save the tough ones for Jim. This presentation tomorrow, you'll receive a quick evaluation from us through the email. Please let us know what you thought of the session, how we did, and also things you want to hear about in the future. You'll also receive an email from us with links to this recording and links to Jim's slides so that you can watch it again or share it with your friends and neighbors and loved ones who aren't here today. So at New Hampshire Lakes, we are the only publicly supported nonprofit organization working to protect all of New Hampshire's 1,000 lakes. And I know many of you on the call this evening are New Hampshire Lakes supporters. Thank you for your support, helping us get this critical work done. And if you're new to us or not yet supporting us, please do consider supporting us. Our supporters help us bring programs like this to folks like you. So our mission is to keep New Hampshire's lakes clean and healthy. We do this in a number of ways. We have an advocacy program where we work with our state representatives in the legislature. We have conservation programs. Many of you may know us through our Lake Coast Courtesy Boat Inspection Program. We're in our 20th year of preventing the spread of invasive species, teaching boaters how to take simple steps to keep their boats clean and prevent the spread of things like milfoil. We have a relatively new program, the Lake Smart Lake Friendly Living Program, where we help folks find out simple things they can do in their homes, around their homes, along the water and out on the water to keep these lakes clean and healthy. And of course, we do outreach and we we work with families at festivals, engaging kids in fun games where they learn a little bit about ecology as well. And we bring webinars like this to folks like you as part of our outreach. Before we get any further, I just wanted to also introduce and welcome and thank our sponsor, Grapponi Automotive Group. They are a longtime supporter of our work. They have sponsored this webinar series very generously, and they help bring this to you. And if you need a car, they're always the first place I go to look. And again, this evening, I'm Andrea Lamoureux, president of New Hampshire Lakes, and Soren Denlinger, our business and development assistant there, is going to be moderating as well. And he has a special passion for geology as well. So, but without any further ado, your expert presenter this evening is James Vernon. And I'm going to turn it over to him. So, James, you should be able to share your screen. And that is looking good.
Okay, can everyone hear me?
And
Andrea,
yes, I can hear you loud and clear.
Great. Well, I'm going to start right in. Thanks, Andrea.
Take it away.
Thank you to everyone for inviting me. And so we're going to talk tonight about the geology of New Hampshire's lakes. It's a big topic, so we'll do what we can to hopefully give you some interesting insights or information and I'm happy to take some questions, whether they come in the middle or at the end. So here we go. See, how do I advance this? That's a basic question. All right. So here's Lake Winnipesaukee at Weirs Beach, and we know that our lakes, geologically speaking, are relatively young. The glacier or the ice age had something to do with it, as we all know, but not the only thing to do with it. So we're going to get into that in a little bit of detail this evening. So everyone's heard about the glacier or the ice age. It's a fairly radical concept, and years ago, people weren't convinced it was true. And there are many lines of evidence for the fact that New England was entirely covered by ice at one time. And we're not going to go through all of that, but I'm sure everyone who lives in New Hampshire or knows New Hampshire has seen a stone wall, and not at the base of a cliff. So these rocks just didn't fall off the cliff, and it's not in a river, so they didn't get washed down the river. You can, however, see that they're a little rounded, which means they've been tumbled along and carried by something. If you look closely at the rocks in a stone wall, typically they're not all the same. They're quite different. So even if you don't know the names of the rocks or the names of the minerals, you can tell that they had to come from somewhere else and not all the same place. Sometimes you see really big ones just sitting plunked right on the ground, not outcroppings of bedrock, but a boulder that's sitting on the surface, like Madison Boulder off Route 113 in Madison. This was deposited by the glacier. And again, it's not at the bottom of a cliff. It's not in a river. How could it get there? Really, an ice age or glacier is the only way that anyone that I could think of that it could be there. Sometimes we see boulders on the top of a ridge in the White Mountains that are different from the others. How could a boulder like this possibly get to the top of the ridge except by a glacier? And again, it's rounded off, where some of the more local rocks that you're seeing that have broken off of outcrops nearby are angular. And the glaciers didn't just deposit things, they caused erosion too. This actually would have been by meltwater, probably from a glacier, with stones in the meltwater swirling around in an eddy. Now, why do I say it had to be from a glacier? You can see potholes in brooks or rivers. This one is on the Caps Ridge Trail in Mount Jefferson, not where a riverbed would be, again, up on the ridge. It's hard to think of any other way you could have flowing water up there except from a glacier that's melting. But the glaciers aren't all of the story. Our lakes are formed or dependent or affected by the geology underneath. In this case, the type of rock. This is the old bedrock geologic map of New Hampshire, and we're not going to go into detail, but I'll point out a few things. You see the red round blobs, like the Ossipee Mountains, a little bit right of center. Over in the western part of the state, the patterns, and each color represents a different rock formation. The patterns are kind of striped or forming lines. These are layered metamorphic rocks, where the more resistant rocks form ridges and the less resistant rocks form valleys. But much of the state has these big blobs of color, like the pale green, a little bit right of center, and you may not see it too well, so take my word for it. Lake Winnipesaukee is within that mass of pale green, and Squam Lake up to the northwest of Winnipesaukee. We'll be talking more about these in a minute. So we think about our lakes and the glaciers, and climate, as we know, and it's certainly in the news, has been variable over the years before human beings started messing with it. There's been cold cycles and warm cycles. This was an unusual May when there was still ice in Squam Lake. But if the temperature drops just a few degrees and we get a lot of precipitation, snow will stay on the ground all year round and build up gradually till it's thick enough to form glacial ice. So we're going to step back a little bit to put this into context. We're going to look at the Earth's history. It's roughly 5 billion years old. Geologists think between 4 and 5 billion years we'll round off to 5 billion and put this into perspective. And we're going to pretend that the 5 billion years of Earth's history was all compressed into 1 year. I think it makes it easier to understand. And I know I can't really contemplate 5 billion years, that much time. So New Year's Day, we'll say the Earth formed. We don't know too much. We don't have much of a record until March or April of the year, 3 to 4 billion years ago, when the oldest known rocks were formed. These aren't in New Hampshire, though. The rocks are dated by radioactive dating, and some of the oldest ones in the world are between 3 and 4 billion years old. Now we're skipping all ahead to September 1st, about 1 billion years ago. At this time, we know there was life on Earth because their fossils have been found, still invertebrates. None of these from this age in New Hampshire, though. So we're just walking ahead quickly, whirlwind speed here, to what's called the early Devonian period, 395 million years ago. At this time, New Hampshire was covered by seas. And at the bottom of these seas, mud, sand, and lime deposits were formed. A few marine fossils in rocks from this age that were not completely melted or squished away have been found up in the Littleton area mainly. These sediments formed at the bottom of these seas compressed into layers of sedimentary rock. And we won't go through the detail of the different rock types. Skipping ahead, 350 million years ago, the mid to late Devonian period, as it's called by geologists. This was a time of mountain building in New Hampshire. The Earth's crust was subject to tremendous pressure and some heat. The sedimentary rocks were compressed and squeezed into layered metamorphic rocks such as schist or gneiss or slate. And an example of this is the Littleton Formation. We also had igneous rocks, rocks that were molten. And molten rocks could either erupt on the surface as volcanoes or cool more slowly underground as plutonic rocks. And some major New Hampshire formations were formed at this time. The Kinsman Quartz Monzonite and the Winnipesaukee Quartz Diorite are a couple of these. If you're not a geologist, you may not realize it, but geology is afflicted with word disease. We name everything we can think of. So please bear with me. I'll try not to get into too much jargon. Here's some pictures of one of those rocks I just mentioned, the Kinsman Quartz Monzonite. I call it the 55-mile-an-hour rock. You can still see the white blobs of feldspar even if you're driving by at 55 miles an hour. The outcrop on the right is on Route 104 between Meredith and New Hampton. And I mentioned the Littleton schist. This is one of these metamorphic rocks that shows up in layers, and it's very common throughout the state. It was formerly a sedimentary rock that got heated and pressured into these layers of metamorphic rock. And then the Winnipesaukee Quartz Diorite, which was the pale green I showed you where Winnipesaukee is located. It underlies much, although not all, of present Lake Winnipesaukee. And this was one of these igneous rocks, but it cooled slowly beneath the Earth's surface instead of erupting as a volcano. So I've mentioned a few of the bedrock types, and we're not going to go into detail. I won't be giving you a quiz at the end of this. So the sedimentary formed at the bottom of the seas in layers. The igneous rocks that were molten, they could either erupt as lavas or cool slowly beneath the Earth's surface as plutonic rocks. Very widespread in New Hampshire. And the metamorphic, which some would argue might be the most common group in New Hampshire. These started off as either sedimentary or igneous, but were heated and pressured, not enough to melt them, but enough to squeeze them into layers. The Littleton schist that I showed you is one of those. So we're jumping ahead quickly now, December 15th on our year, 225 million years ago. It's what's called the Triassic period. This was the age of dinosaurs. There have been no dinosaur fossils discovered in New Hampshire. We don't have any rocks of that age that could have preserved fossils. But if you drive south down I-91 into Massachusetts, you start seeing red rocks that are of this age. They're sedimentary rocks, and dinosaur tracks and bones have been found in those rocks. And you can go to Dinosaur State Park in Connecticut if you want to see them. They've preserved some dinosaur footprints that were found in the red beds. These were rocks that were not formed under the ocean, but probably in riverbeds or mud flats, and the dinosaurs walked across them, and we still see their tracks. You've probably heard of plate tectonics. We're not going to get into that, but this was a time that North America and Eurasian plates were splitting apart. New Hampshire was above sea level at this time, subject to uplift and erosion. Jumping ahead, still in December, 180 million years ago, the Jurassic period, the first birds. Some of those red blobs that I showed in the geologic map, a second pulse of igneous activity occurred in this time, including both volcanoes and these plutonic rocks. Ospey Mountains formed at this time. So we're jumping way ahead. New Year's Eve now, 8 p.m. This is when it gets interesting for lakes. This is the start of the Pleistocene epoch, the ice ages. And we know from the record that there were at least 4 major advances of ice in North America. It's also the time that human beings evolved. So again, thinking about how could New England be covered with ice? Well, these ice ages, of course, started in Canada, but as I mentioned, it doesn't take a big climate shift to the colder and wetter for snow to last all year round. Here you're looking at Mount Washington and Mount Jefferson. This picture was taken in May, and as you know, snow has been recorded on Mount Washington in all months. So it would have to be somewhat colder and farther north, but if the snow and ice piles up, it can get thick enough that the pressure melts some water at the bottom of the ice and the glacier starts to flow. So skipping way ahead, 2 years before midnight on New Year's Eve, the last of those 4 glacial stages, known as the Wisconsin glaciation, because a lot of the features of that ice age were studied and discovered in Wisconsin, took place. All of New England was covered by ice. The ice extended as far south as Long Island, which was actually the terminus of it. Long Island is a big ridge of gravel that was bulldozed there by the ice age. Cape Cod, Martha's Vineyard, and Nantucket are formed the same way, different stages as the ice stagnated. The edge of the ice stagnated, I should say, but the ice was still flowing and bulldozing material in front of it. For a time, people thought, okay, well, New England is covered by ice, but the highest mountains probably stuck up above the ice. But they actually have found boulders on Mount Washington that are distinctive enough in their rock type that don't come from there and can be identified with places 10 miles or more to the north where that particular rock had to originate. So the only way a boulder like that could get to the top of Mount Washington was by the glacier. At this time also, though, the glacier plowed over the mountains, but it scooped out little basins here and there, which are now filled with water, like the Lake of the Clouds that you see in the foreground. The Lakes of the Clouds Hut, which you might have hiked to, is out of sight off to the left. The glacier had dramatic effects on the land, as you can imagine. And when I was a kid, the first time I heard about the glacier, I thought, well, you know, it's just this massive clear ice cube. Well, it's not that at all. They were very dirty. As they traveled down from Canada, they picked up all kinds of stuff: boulders, cobble, gravel, sand, clay, silt. Some of that was entrained in the ice. Some of it was pushed in front of the ice like a bulldozer, and some of it was along the bottom of the ice. So the ice scraped away everything, pretty much, all the soil that had been there before, the vegetation, and it acted like sandpaper in some places, making grooves in the rock. So these glacial grooves can be seen here and there. This one is on the trail up Rattlesnake Mountain in Holderness. About a third of the way up on your left, you can see this. And geologists, excuse me, I just got a battery warning light. I hope I'm okay now. Geologists are interested in these, not because they show the power of the glacier, but because they show which direction the ice was moving also. So they find these rocks with the glacial grooves and they study them, measure the directions, and they can work out which way the ice was flowing when it crossed this particular spot. I don't know if the power strip, I flipped it, so I don't know if it may be on now. Excuse me, sorry about a technical issue here. Another feature formed by the ice called a glacial cirque. These are U-shaped valleys in the mountains where you had glaciers still in the mountains persisting after the rest of the ice had melted away. This one's King Ravine in the White Mountains, but you've probably heard of Tuckerman's Ravine or maybe hiked into it. Huntington Ravine, Gulf of Slides. There are several of these cirques in the White Mountains, another glacial feature. So now we're at 1 minute before midnight in our year. This is the time when the ice age began to retreat. Now, sometimes I have to remind myself, the ice didn't turn around and start flowing north. It actually was still flowing south, but it was melting faster than it was gaining. So the margin of the ice retreated, but it still had some power to push more rains and to grind what was underneath it. Meltwater rivers, as you can imagine, as the ice were melting, tremendous rivers flowed off the front of the glacier. Temporary lakes were formed if these rivers met an obstruction or dammed up, and we'll talk more about those. And many of our present lakes were formed at this time as the glacier was melting. Really just a minute out of the Earth's history, if the Earth's history was a year. Sand and gravel aquifers were left behind by these rushing meltwaters as the sand and gravel from the ice dropped out of the water as the water flowed, usually to the south. Soil was formed during this time. Almost all the soil we see in New Hampshire is younger than the glacial retreat because the glacier scraped away everything that was there before, including the plants. Plants that had survived farther south of New England, their seeds blew in, they began to recolonize New England. As all that ice melted, the sea level rose, and we hear about sea level rise now as some of our ice caps are melting. That happened in a big way as these glacial ice sheets melted. Sea level rose considerably, and the sea level extended up some of our river valleys quite far inland, as far as Freiburg, Maine, for example. Also, you can imagine with the weight of the ice removed from the land, it's almost like breathing a sigh of relief. They've documented that the crust actually rose a bit, rebounded sometime after the ice left. So now we're getting to the lakes. Most of them, as we said, formed either partially or totally due to the glacier and since the glacier retreated. So here's some of the types that we're going to talk about. First one, artificial lakes formed by damming up rivers usually. I'm not going to talk about those so much. I'm not so interested in those, but they're around. And south of the glacial limit, that's mostly the only way you get a lake. Not the only way, but here we're fortunate, I think, in New England to have these other types of natural lakes. So the first one I want to mention is these large basin lakes like Winnipesaukee and Squam and Sunapee. These we'll talk about in a minute. And then tarns, which are these little beautiful lakes in the mountains. We'll talk about those two. And then we have another type formed after the glacier melted called kettle ponds or kettle lakes. Then we have oxbow lakes along some of our major rivers. And of course, beavers, some lakes are quite new, the beavers can make them. Another way a lake can be made is a stream getting dammed by a landslide. And then, as I mentioned, we have these temporary lakes formed from glacial meltwater. So first, we'll talk about excuse me, I'm getting a low battery warning again. I'm going to see if I can fix this. All right, hopefully I fixed it. Apologize for that. These large basin lakes like Winnipesaukee and Squam and Sunapee and many others, most of our big lakes were formed by the glacier grinding out broad basins in the rock. They're more commonly formed in these big blotches that I showed you on the map originally, like that light green blotch, in these igneous plutons, these big masses of igneous rock. Now, you can hardly say that any of the rocks in New Hampshire are soft, but some are softer than the others. And the glacier was able to grind these away. And if it formed a basin, then the basin can fill with water. They do occur in metamorphic rocks also, but not so much so because those rocks are layered and you often have harder, more resistant layers alternating with softer layers. So you could have lakes in the soft layers, but more likely you had rivers flowing along the softer layers. And for example, if you look in Vermont, on the map of Vermont, there are way fewer lakes in Vermont than New Hampshire. Well, why is that? Well, they have a lot of these ridged metamorphic rocks in Vermont, not so many of the big igneous plutons that are subject to being gouged into basins by the glacier. There are some exceptions though, and I've mentioned some of the examples. You can also have small lakes gouged out of the rock too. It's not just the big ones. We mentioned Winnipesaukee, that's the obvious answer. It's mostly underlain by this Winnipesaukee quartz diorite, which is a broad igneous mass, and the glacier was able to gouge it into a basin, which then filled with water. Winnipesaukee has an interesting story. Before the glaciation, geologists think it was a lowland, and there was probably a series of marshy rivers flowing through it. They'd been wet. There's probably a lot of weathering, chance for water to get in the cracks of the rock. So the igneous rocks may have been weathered and softened, if you will, a bit. Then the glaciers came, they moved generally from northwest to southeast, and they scoured some of those weathered rocks out, forming the basin. Then the ice gradually melted and retreated to the northwest. The basin filled with meltwater. At that time, the present outlet of the lake at the weirs was dammed by ice. The lake was several feet higher, the lake level was several feet higher than it is today, and the outlet was at Alton Bay at that time. If you drive through Alton Bay on Route 11, let's say you're heading east, you'll see the lake on your left. It's a long, narrow cove or inlet, as you know. If you look down on your right, there's buildings, but if you look in between the buildings, there's a very low, marshy area down there. It wouldn't take too much to envision a river spilling over Route 11 and then flowing down into that lowland. So that was the outlet at one point. Eventually, though, the ice retreated. The water broke through at the weirs, flowed down into Paugus Bay, and then down through Lakeport and down the Winnipesaukee River towards Tilton and Franklin, as it does today. This drained the lake down to its present level. Now, I was mentioning dams. Many of our natural lakes do have dams on them. It doesn't mean the dam formed them, but it's a way of controlling the lake level or maybe providing hydropower and so on. So here's a view of Winnipesaukee, and now that's sort of a brief story as to how it formed. But I mentioned the glacier gouged out small depressions also, especially in the mountains. Here's lakes of the clouds again. Now we're going to talk about tarns. These are small lakes in the floors of these glacial cirques, these U-shaped glacial valleys that form in the mountains. As I mentioned, there are a few of them in the White Mountains. There are lots of them in the Alps and various places around the world. A few examples are Hermit Lake in Tuckerman Ravine, Spalding Lake in the Great Gulf up in the Whites. These were formed as glacial remnants carved out the cirques, and the glaciers didn't just flow evenly. They gouged out depressions here and there, and those filled with water. The tarn term is loosely used for lakes up on mountain ridges too, and many people call any little lake in the mountains a tarn. That's not necessarily wrong, but the official definition are the lakes in the bottoms of ravines. But lakes of the clouds, the Star Lake between Mount Adams and Mount Madison, those are examples of lakes that are higher up on the mountain ridges. And again, they formed basically the same way. The glacier gouged out basins in the rock. And there's Hermit Lake in Tuckerman Ravine. I should say I did not take all these pictures, especially this one I got off Google Images. So don't want to claim credit. The next one we're going to talk about is kettle ponds or kettle lakes. Unlike this first group I've been showing you, these were not gouged out of rock. These are formed in sand and gravel deposits. The sand and gravel was outwashed from the melting glacial ice. As these rivers flowed back and forth off the edge of the ice, they deposited sand and gravel. But sometimes a big iceberg or a big chunk of ice floated a little ways down and then dropped into the gravel. So some of it was probably sticking up above the gravel, some of it was maybe in the gravel. When that big block of ice eventually melted, it formed a hole, a circular depression. If that depression extends below the water table today, then there's a lake there. Or there was, it may have been filled in by plants or sediment now. These classic kettle ponds are often circular. They don't have to be. They often have no inlet or outlet. They're just expressions of the water table. Sometimes they do have streams trickling in, but typically they don't have a major river draining them. One of the largest ones I know of is White Lake in Tamworth. Most of the classic kettle ponds are smaller than that, and they're very common on Cape Cod and other places as well. So there's a picture of White Lake, and you can see it's kind of, the hills around it are not high. It's in relatively flat terrain. It's not in a steep valley or anything like that. And you see an aerial view of it. It's not circular, but it's more or less a blob, and there's no evidence of a major outlet river, major inlets either. There's trickles of little streams that flow into it, but it's a good example of a kettle. Here's another one, and this one is not directly formed by the glacier. Oxbow lakes. These are formed from meanders in rivers, and sometimes these meanders get cut off when the river changes its course. If it's a big river in a broad valley with lots of sediment in the valley, the river can erode these curving pathways that you've probably seen, but then in a big flood, it may completely cut an oxbow off, forming a lake, like Horseshoe Pond in Concord. Another example would be streams that are dammed by landslides. Lost Pond in Pinkham Notch, which is on the Appalachian Trail and not too long of a hike from the Pinkham Notch camp, if you want to see it, is an example of one of these. You'll notice from its shape, it's longer and narrower, so you can see how it could be a stream that was dammed up, as opposed to being like a round kettle pond, which typically is not part of a stream. So now we're going to talk about one of the last ones I mentioned, and it's a little more complicated. You may not realize there formerly were big lakes over many parts of New Hampshire that aren't here now. These formed as the glacier was melting. They typically formed in valleys. A lot of them were in valleys that are currently rivers, although some of them occurred in places where there is not a river today or a lake. And many of the rivers that we see today, the Merrimack, the Connecticut, and so on, were much, much larger than they are today when the glacier was melting. Huge amounts of water were rushing southward. But these former glacial meltwater lakes often formed in present river valleys, not always. And they formed when a meltwater river got dammed up. Sometimes that was by ice, or sometimes it was by one of these moraines that was bulldozed forward by the glacial ice. If it blocked the course of a meltwater river, then the water backed up behind it. This quiescent water, any sediments that were carrying would drop out of the water and sink to the bottom. So you got lots of clays and silts formed. The coarser grains would drop out farther upstream where the water was still going fast and then just start to slow down. So some of these glacial lakes actually have deltas that formed in them. The lake's gone, but you can still see these delta deposits. These lake beds have been explored. They can see pollen in them, and they take cores from them, and they can see, get an idea of how long the lake was there by the different seasonal layers, what plants might have been starting to recolonize the area by then, by the pollens. And so they're fascinating to study. Most of these are gone. The water eventually broke through the ice as the ice melted, or the moraine dam, the water eventually overtopped it or breached through it. So some of these lasted, a few decades, maybe even 100 years or more, but they were temporary and they're gone now. So we're going to look a little bit at an example of one of these. It's actually a pretty complex series of lakes that formed in the Kentucky River Basin. The Kentucky River, as you may know, it's a little unusual in New Hampshire because it flows north. It rises in the Jaffrey Ridge area and flows north to Concord, Pennacook. So that presents kind of an interesting case because you can imagine as the front of the glacial ice was retreating to the north, the meltwater would melt off the ice, but then try to flow down the valley towards the north and then meet the ice and get trapped. So this was an ideal situation for glacial lakes to form. And they've worked out a very complex sequence of 8 different stages of lakes. And we're not going to go into the details here, but each pattern you see on that map was a different stage of the lake, with the oldest ones being to the south, which was the headwaters of the Kentucky. Remember, it was flowing north, but there was still ice there at first. So the first lakes were very small. The water melted and then flowed back north till it hit the ice. At that time, as we mentioned, the ice to the north presented a dam. So sometimes the water would find an escape route, and the little arrows you're seeing are the way the water escaped the lakes during these times. And there are little meltwater channels that can be found. That's how they think this happened. So they've worked out in quite detail these 8 different stages of lakes. And you can see, for instance, by the number 4, some dark lines there, that was the northernmost extent of the stage 4 lake. The ice was at that point. And then as the ice retreated farther north, the stage 5 lake, which was much bigger, was able to form. And its drainage way was out to the east across that dashed dot line, which is the drainage divide today. So gradually, as the ice retreated, the lake level dropped, moved farther to the north, and occupied a different area. And this is all worked out from the sediments in the valley and the evidence of these drainage channels. So it's quite a complex scheme that was worked out. It's the kind of thing that geologists sink their teeth into sometimes, but it also gives a fascinating view of the start and stop retreat of the glacier in New Hampshire. Now, these lakes weren't always big, occupying a whole valley like the stages 4 and 5 in the Kentucky. They formed fairly small basins in some places. This is Whiteface Intervale in Sandwich. You're looking up towards Mount Chicorowa there. One of the few areas in our neck of the woods where farming can take place is in these former lake beds. This was a former glacial lake, much smaller than the one I just showed you, but it filled that Whiteface Intervale, and Wanalancet Intervale nearby is another one. And you've got quiescent lake bottom sediments here, fine grained, not too many rocks in them. Makes for comparatively decent farmland compared to most of the rest of New Hampshire, where farmers had to dig boulders out of the ground every spring. So these intervales are also examples of former glacial lakes, dry now, but if you stand there, you can imagine a few feet of water would have been over where you're standing for some period of time. So now we're almost done our year, December 31st, New Year's Eve. And that's when the New Hampshire Lakes Association was formed. So I hope this puts it all in perspective to you. I know I talked very quickly and leave you with Squam Lake. And I guess the moderator may be taking questions. I'd be happy to field them if I can.
That was really cool. Thank you for taking us on that journey, Jim.
Well, you're welcome. I hope I didn't talk too fast.
I appreciated you kept it interesting, but at a level that wasn't too geologist-like. So thank you.
Yeah, I know. I didn't get into all the minerals and rocks, or tried not to. So
you talked a little fast. You covered 5 billion years in an hour.
Yeah, I guess so. That's pretty good, isn't it?
Yeah.
Well, I will turn this over to you, Soren, in the event that you have any questions or the audience has any questions.
Both. David asks, how much larger was the Merrimack when the glacier was melting? And are we talking twice as wide or more? And I believe he's referring to the river there, but
yeah,
it could also be there.
There were actually, I was just reading this last night and I won't remember them all. There were 2 or 3 different glacial lakes in different parts of the Merrimack. There was Lake Hooksett, that's the one I remember. And so I'm guessing here, based on the Kentucky, which the lake there was probably 5 or 6 times the width of the present Kentucky River. Merrimack, of course, is a bigger river than the Kentucky, but I would say it was at least twice as wide, maybe 4 times as wide. It didn't occupy the whole river valley. It was segmented. I will mention also the Connecticut River at one time was dammed all the way down in Connecticut, and that lake extended up through Massachusetts all the way into New Hampshire and Vermont, Glacial Lake Hitchcock. And there are deltas from that lake that are on the hillsides 100 or more feet above the present river in elevation. So the Connecticut River is a long, narrow river valley, but I know Glacial Lake Hitchcock was 2 or 3 times wider. It filled pretty much the whole valley that we see today. So some of these lakes were huge, even though they didn't last terribly long by a geologist's reckoning.
Yeah. So the follow-up question to that is, would present-day Concord, New Hampshire be underwater when?
A lot of it, probably not all of it. And there's a broad valley there, but you've got the heights, and then as you get up towards White Park on the west side, you're pretty high up there. So I don't think the whole city would have been underwater. I don't know just how far the lake reached in the Concord area, but certainly the whole present valley, I would just guess, up to Store Street on the west side, Basically, the whole lowland was probably underwater, but I don't know for sure.
I know from a little cursory research that our headquarters in the Heights is located on a delta from the Suncook River emptying out into the lake over Concord. So at least the Heights was underwater.
Yeah, and the soil here is very sandy. My office is right across the street from yours. I work at Nobis, and the sandy soil here, which supports the pitch pines and the sweet ferns, and it's fairly unique bird life too. So that fits with what you're saying. The delta is where a lot of the larger sands and gravel grains dropped out of the water, and then the finer grain silts and clays stayed suspended longer and then dropped down when the water was actually still in a lake. So that makes sense.
Great. Okay. Evelyn asks if you could please discuss iron a little in lakes. They heard that iron was mined in Kingston Lake, and I know that iron was mined in Crystal Lake, where I am at Gilmanton. I don't know if you knew anything about that.
Well, I know that many of the rocks in New Hampshire are iron rich. Some of the formations more than others. The Rangeley Formation, which is one of the dark schists, metamorphic rocks, has a lot of iron in it. And if you drive up 93, you see many rusty outcrops as you go north of Concord, just from the abundant iron. I don't know specifically where the different iron mines were, but iron is a fairly common constituent in the water. It can be dissolved in water, and some of the groundwaters as well as the surface waters have a lot of iron in them. But it's naturally derived, but I can't speak to the specific lakes.
Well, apparently there's a lot of it, because right next to Crystal Lake, there's Gilmanton Iron Works.
Yeah.
Enough to make something. I have a question from Carl here. Are all the sand and gravel pits in New Hampshire in deltas formed in glacial meltwater lakes?
Not necessarily. You had sand and gravel in various different formations as well as deltas. You had what's called kames, which were deposited by meltwater rivers along the sides of valleys typically, and we didn't get into this much, but there's a whole suite of interesting glacial formations, kames, eskers, outwash plains. So as you can imagine, as the glacier melted, sometimes there were basins like we were talking about for these lakes, but sometimes the glacier's remnants were confined in more linear valleys. And so you had sands and gravels deposited by meltwater streams underneath the glacier or along the sides of the glaciers up against the hillsides. Sometimes you see little cemeteries sort of plastered up against the hillside. Those are often formed in kames where the ice was up against that hillside, and as it was melting, the meltwater stream deposited sand. Other places you have vast plains of sand and gravel like the Ossipee Plains, and meltwater rivers probably just were braiding back and forth across there. So it's not really a delta, it's more of a sand plain. And then in the river valleys themselves, there are often just layers of sand and gravel that formed, again, during melting. And these are actually the best aquifers in the state. Best place to find high yielding wells are in these sand and gravel deposits. So deltas is one, but not the only one.
Great. I see Laura has a hand raised. I don't know if that's a question or a misclick, as I often do. Well, Laura, you can put the question in the chat box or send it to me, and I'll ask it. But I have a question, since we have a little time. I want to know how geologists investigate what the bedrock relationships are underneath Lake Winnipesaukee. Has that been surveyed, or is it just kind of inferred from what's around it?
A lot of it is inferred. There are islands in the lake, and most of those islands are rock cored. So, the glacier gouged out a basin, but it didn't do a complete job. And in fact, the Belknap Mountains, the bedrock geology is complex there. It's one of these ring complexes. Some of the islands near the southern edge of the lake are extensions of the bedrock from the Belknaps. Some of it may come from drilling wells. People have camps out on the islands. If they get a drill rig out there, manage to get a drill rig to the island, or are out on one of the peninsulas and drill a well, those go several hundred feet deep, and that gives us an idea of what the rock types are. But some of it, I'm sure, is inferred.
Right. Makes sense. There's no giant research vessels out there coring Winnipesaukee.
No. Some of the smaller ponds, though, and bogs have been cored for study. And as I mentioned, just the pollen sequences and the sediment sequences allow them to work out a lot about the climate fluctuations and the plants recolonizing and so on. But the big lakes, you'd have to get a big barge out there with a big drill rig if you really wanted to core down into the rock. So a lot of it is inferred.
Great. I have a question from Warren here, and is that does the genesis of the lake, be it through a kettle lake or an artificial lake or just carved out by the glacier, does that ultimately predict the water quality?
To some extent, yes. Deep versus shallow, that's going to influence oligotrophic versus eutrophic lakes. The type of rock probably indirectly affects the amount of nutrients that are in the lake, because when the glacier, ground through the rocks, it eroded some sediment, and a lot of that sediment is now at the bottom of the lakes. And so that's going to affect the nutrient status of the lake, whether the lake's deep enough to have a temperature stratification and a turnover is going to affect it. The kettle ponds often are quite small, and because they often have no inlets and outlets, they often get filled with boggy plants. You have the floating sphagnum mosses and so on, and so the acidity of those can be very acid. So certainly indirectly, the rock type, the soils that are washed in by the rivers, if there is a river, the amount of water circulating through the system, all of those factors, I think, will affect it.
Great. And I have one more question, since we have time, and I want to know is, in 1 million years or 5 million years, or some other suitably broad time span, would a geologist then know that New Hampshire had lakes?
Yes, I would say so, because there are enough deposits formed at the bottom of these. And as I alluded, the types of deposits you get in a lake bottom are different from what you get around the edges. You get coarse, sandy materials in the deltas around the edges, but those materials drop out before you get to the center of the lake because there's not enough current to keep sweeping them forward. So sediments under a lake are typically silty and clayey, and you find these and you think, it was deposited in quiet water. Then you ask, was it salt water or fresh? Well, if you can find any kind of shellfish at all, be it still preserved or fossilized, and you can identify the species or the type of organism, you can tell if it was a saltwater or a freshwater creature. I mentioned during the sea level rises, the sea level extended up, and this was before the crust rebounded, but while the sea level was higher, the sea extended up a number of the river valleys and deposited these blue clays, very common in Maine particularly. And they core these, they find marine shellfish in the clays. So that's part of the evidence that it really was from seawater and not a freshwater lake. So I think geologists would be able to tell that there had been lakes there from the sediments.
Great. As you were explaining that, I was thinking, I had just read that yesterday or today even, that there were turbidite deposits in Sunapee from underwater landslides. And if I was being the lazy geologist that I might be, if I found a turbidite, I might just assume that's ocean. I would. It didn't cross my mind that you could get those in lakes. So that's.
Well, I'd never heard of that, but there's, I guess, no reason why it couldn't occur if you had enough unstable material and a steep enough slope. Maybe I should step back if not everyone knows what a turbidite is. It's basically a deposit formed by an underwater landslide. So they typically have a mixture of cobbles and sand and gravel, a range of sizes of deposits. They probably didn't travel too far, so they're not as rounded off as a rock that, or cobble that had been tumbled for several miles down a river. And there are, major turbidites that form under the ocean, but I hadn't heard of one forming in fresh water, but I don't see why it couldn't.
I had the same thought process. There's one more question from Liz. That says, is there a layperson level book you'd recommend for someone who wants to get a basic lake education? I guess that could be for you or for Andrea, that question.
There were a couple of books that I used to prepare the talk, several actually, but no one book. Maybe Andrea would have a better idea than me. And I confess I don't remember the name of the book that I relied on the most. It was Lakes and Ponds of the White Mountains. I don't know if I have the title right. They have a nice chapter just on the lakes, and I actually used that quite a bit. If someone wants to send their email address to Andrea or something, I could get the exact title and email it to them. But maybe Andrea, you might know of a book to recommend.
Yeah, that's a great question, Liz. And of course, I'm an aquatic biologist by training, so I've read a whole bunch of nerdy books that I wouldn't recommend to you guys. But there is a book that I do recommend called Pond and Brook by Michael J. Caduto. And I know it was out of print for a little while, so I actually just went on, and I do see that it is available on Amazon presently in a couple different options. Again, Pond and Brook by Michael J. Caduto, Caduto, is something I would recommend. Great question.
Great.
Awesome.
I believe we've breezed through our questions. Oh, one more under the wire.
Yay, Carl.
Yeah, Carl's sliding in here. There are some huge potholes, he says, in the Ammonoosuc River close to the Cog Railway, 2 to 3 meters wide. How big was the river then?
Well, I don't know. I've seen big potholes too in small brooks. So, it had to be big enough to carry stones that were large enough to grind that pothole out. And it had to be big enough, long enough, because those don't form quickly. So I think it's fair to say the Ammonoosuc was bigger than it is today. Of course, you're probably near its headwaters there, but even so, as snow and ice was melting off the mountain, I don't doubt it was considerably bigger than today, but I don't know how much bigger, but certainly big enough to form those potholes. And the ones I showed the picture of, they're up on the Caps Ridge Trail about a mile up on Mount Jefferson. That's right up on a ridge, not even in a river valley. So if there's enough moving water to form those, it's not hard to see how there could be big ones in a present river as well.
Great.
Well, awesome. We're right at the 8 o'clock hour. And it looks like Donna put another recommendation of a book in the chat. So thank you, Donna. And I think we'll wrap it up here. Thank you, Jim, so very much for presenting.
Well, you're welcome.
Yeah.
Thanks everyone for listening in. And
Absolutely. And thank you, Soren, for your excellent moderating. And thank you all who tuned in today. Again, tomorrow you'll receive an evaluation form in the email. Please let us know how we did. And please let us know the topics you want to learn about coming up. We are still finalizing our fall schedule, our webinar schedule. We will be going monthly, first Wednesday evening of the month for the next several months. And we're just putting the finishing touches on that. And again, you'll get an email tomorrow with links to this recording and to Jim's slides. So happy September. Enjoy the last few official weeks of summer, and we hope to see you all back here in October, the first Wednesday evening in October. So take care and stay safe.